The New Zealand swamp Kari trees. Hi, I'm Joel Duff, and I want to talk about an ancient history revealed in tree rings. Along the way, we're going to be talking polarity reversals, climate change, young earth creationism, and that's a whole lot to talk about, so we better just get started. What is a Kari tree? There's actually many different species of Kari trees, mostly found in Australia, but there is one particular species that lives in New Zealand. It's the only species that lives in New Zealand. It's an evergreen, similar tree related to pine trees. This is Agathis Australis. Don't know why it's called Australis since it only lives in New Zealand. Very large tree, up to 150 feet tall, trunk up to 15 feet in diameter, and as you can see, only is found in the northernmost tip of New Zealand. So why are we interested in these trees? It turns out that there is an interesting phenomena by which these trees have been preserved in swamps, peats, lowlands, underneath sediments in very good condition, which has allowed these trees to be exhumed and, as we're going to see, cut open and their tree rings examined, which allows us to look at not just present-day history, but past history of these trees. And form a chronology or a timeline of the history of this particular forest and these trees in New Zealand. So here is the particular tree of note. All right, there's been many swamp Kari trees, and that's just the name given to trees that are dredged up from underneath the ground. This particular tree was found about 3 years ago when they were excavating an area to expand a power plant in northern New Zealand. It was found underneath 20 feet of clay. This is a 60-foot long, 8-foot diameter tree trunk. It's 1,500 to 1,700 years old when it finally died, so that's the number of rings that it contains. The inside, the very inner portion, is decayed somewhat, so we don't have an exact count of the number of tree rings, but there's at least 1,500 tree rings in this particular tree, and if each ring represents a year, this tree would have been 1,500 years old. Now, what makes this particular tree very notable and important, and is part of a recent publication in the journal Science just this past week, is that the tree rings are dated, at least 1,000 of them are dated between the years 41,000 and 42,000 years old. So carbon-14 data suggests this tree is quite old. So it's a snapshot in time of the years 41,000 to 42,000 or 42,500 years ago. Now, before I show you some of the results of that dendrochronology and what we can learn from these trees, I want to mention that this particular tree presents a particular challenge to a group of individuals called young earth creationists who compress the history of Earth into approximately 6,000 years total. I took this snapshot of a very generalized timeline to show you what the young Earth chronology is of the Earth. You have the creation 4004 BC or somewhere around there, so about 6,000 years ago. You have this global flood about 2,350 BC, so 4,350 years ago. That flood would have wiped out the surface of the Earth and is said to have reconstructed the Earth in terms of its geology. And so all the plants and animals alive today are the result of actions that have happened after 4500 BC. And then you have this ice age, what they think is a single ice age. So they recognize that there is evidence that the world had a much larger volume of ice in the past, and so they call this the biblical ice age, which occurred just a few hundred years after this global flood. So the ice age in their mind occurred only about 4,000 years ago versus 11 to 25,000 years ago, the most recent ice age in the conventional timeline of Earth's history. So now why do I bring all this up? Well, I just showed you this enormous tree that had been dredged up from underneath the ground, which is thought to be a 1,500-year-old tree. And yet it's found in an area that probably has looked like it does today for thousands of years. So where does this tree fit in to this young Earth creation timeline? How do they squeeze in? Like, when did this tree live, and how could it have lived for 1,500 years? Did it live after the flood, or did it live before the flood? Becomes the question. Now, this tree made a lot of headlines just because of its unique age and because of its size a few years back, and so it was in the general news. There's only been one creation scientist that I have found that has been willing to tackle this particular tree and to ask the question, how does it fit in with the flood? And as you can see, Taz Walker, who is a engineer, creation scientist, and is from the New Zealand, Australian area of the world, he writes that this article in what he calls his blog of biblical geology, the giant Kari tree under Earth in New Zealand was ripped up and buried by Noah's flood. So he answers the question right there in the title. He notes that, hey, there's this huge tree, 60 tons. How did it get there? So he admits the article says that carbon dating reveals the tree lived for 1,500 years, and now we know that not only carbon dating suggests that old of an age by carbon dating the inner and outer rings, but also by counting the rings, we see that there's about that many years present, which is a nice confirmation of the validity of C14 dating. Between 41,000 and 42,500 years old. Now, of course, that doesn't fit into his chronology. Nothing can be older than 6,000 years, so he has to answer the question, well, when did it live if it is said to have been 42,000 years ago? Where am I going to put it within the past 6,000 years? So here's what he does, and I think it's kind of, there's a couple things that I think are interesting to note in his discussion about this. So he says, okay, all right, so you got carbon dates from 41,000 to 42,000. Are typical of dates of samples of wood that grew in the pre-flood era and were ripped up during Noah's flood. So he refers to the Creation Answers book, which is something from Answers in Genesis, that develops this idea that carbon dates, all right, so if we were to look at carbon dates over time, he says that a date that is, let's say you dug up something that was 2,000 years old and you were very confident of its age. You know, maybe it was something, an archaeological item that you knew its age and it was 2,000 years old. And then you did C14 dating. They would expect, young Earth creationists would expect that the C14 date would be about 2,000 years old. In other words, they do believe that carbon-14 dating is reliable within the last few thousand years. They pretty much have to believe that because there are so many known objects of particular ages that are dated, and the dates come out to be about what the C14 date suggests it should be. And so they accept radiometric decay and the fact you can measure C14 and then you can calculate ages. So then what do you do when you get dates that are 5,000, 6,000, 10,000, 40,000, 50,000? Remember, C14 dating doesn't do any good beyond, say, 50 or 60,000 years. You have to use other forms of radiometric dating to look at older objects in the conventional geological world. So what if this object is 42,000? How does that fit in? So now here's where my little thing comes in. You know, for a 100-year-old object, for 500, for 1,000, for 1,500, for 2,000, the dates that you would receive are equivalent to the actual real dates. But then at some point, if you were to measure something that was in reality 5,000 years old, all right, you would expect, in their view, to get a carbon-14 date of, say, 15,000 years old. And if you were to measure something that was 5,500 years old, it might be 40,000 years old. And the reason for this is that they project back in the past that there was much less carbon-14 production. And therefore, they're saying that we're reading all of our numbers wrong. And so the farther you go back in the past, the much less carbon-14 there is. Now, there's the evidence for that is somewhat wanting or completely wanting, but it's basically a curve-fitting model where they force in all of the carbon-14 dates into a 6,000-year-old history. And beyond 6,000 years, then you don't expect much carbon-14 to be there at all. Well, anyway, where does 42,000 years fit? In his model, 42,000 years fit into the time period between creation and the flood. So you'd say this tree must have been growing between the creation and the flood. And we can see this admission that carbon-14 dating actually does function properly, except that it has to be tweaked in their model to force fit older ages. You can see that right here. You say, if the flood, what if, if this tree had grown for 1,500 years after the flood, then, and been buried, then it would have only been buried about 3,000 years ago. In which case, any growth in that period from 3,500 to 3,000 years ago would have given a carbon-14 date between 4,500 and 3,500. You see how he's saying it's going to be a little bit skewed? That's because if you go beyond 2,500 years ago, that's where the skew begins, right? That's where the carbon-14 ratios are different. And so therefore the calculations are going to be offset in their model. And they're going to give ages that are the C14 dating. If you just use a model that says that decay has happened consistently, will result in you overestimating the age of the object compared to its real age, which is much younger. So it's saying, well, you wouldn't get 42,000 years ago if the object had grown after the flood. So let's put it before the flood. All right, so we put it before the flood. And of course, he has to note that this is interesting. I mean, the tree is 1,500 years old, 15 to 1,700. How much time was there between the creation and the flood in their model? About 1,600 years. And so this tree is almost about the same age as the time between creation and the flood. And so this tree, in his mind, was starting to grow, or God made this tree, already a few years old, right at the beginning of creation, on the fifth day, and it had been growing all the way up until the point of the flood, and then the flood ripped it up. And then his idea is that it floated on top of all the flood waters that covered the world. And then all the sediments were placed underneath that formed all the mountains of New Zealand, including all the volcanoes that are formed of them. And then somehow the last vestiges of the floodwaters being removed from the land left maybe this huge tree lying on the surface, which then got buried with some further sediments that have happened after the flood. But this is in fact a tree that grew before the flood. All right, honestly, he's forced to do this. Two things. He's already committed to a certain C14 idea of how to understand C14 within a young Earth chronology. And so that particular young Earth date forces him to say that it's before the flood. His other issue, of course, is how could you have a 1,500-year-old tree grow after the flood and still be found 20 feet underneath sediments that are there? Now, he has a couple really big problems. He's trying to answer just where did this one tree come from? In fact, there are thousands of these preserved trees in New Zealand, all over northern New Zealand. So it's not just a one-time accidental event of this tree being preserved, and they're all the same species. So how did all the exact same species collect in just New Zealand and not spread across any other place in the world or ever found anywhere else in the world? If a global flood had been mixing everything up, I'm not sure. But it has bigger problems. One of the biggest problems is that the sediments that this tree is found in are in all other young Earth models of the flood are post-flood sediments. They're things that happened after the flood. They're very, very young sediments. And so it appears that this tree lived and died in a time that other young Earth creationists are saying is a time which occurred after the flood. But there's 1,500 years involved. So either you're going to have to say that it's not really a 1,500-year-old tree, and that the rings don't really count as annual rings, but he seems to accept them as annual rings, and he accepts the carbon-14 dates. This is the kind of conundrums that young Earth creationists get into. They create a model to try to explain one problem with carbon-14, and then when they try to interpret other things like, oh, there's this tree, it has this age, and they try to lay their interpretation of their carbon-14 on another object, it doesn't make any sense. And that's because maybe the original model of their carbon-14 was a forced model to try to force the data into their particular model. And since it's forced and not natural, it ends up creating problems with lots of other forms of data. But we can go well beyond that and show that there is a whole raft of other issues with Taz Walker's interpretation of this particular tree. So I want to highlight a couple things, hopefully fairly quickly here. Here's an article from Quaternary Science Reviews, just in 2018, around the time that this tree was found, emphasizing that it was already known that New Zealand's swamp Kari, these trees that are preserved in swampy swampy soils that preserve the wood, there was already recognized that there's a lot of scientific value in it. And this whole paper talks about all the things we can learn about the past by looking at these trees. There's an entire industry in New Zealand that's all about digging up these trees. And because of how well preserved they are, even if they're 1,000 years old or 15,000 years old or 50,000 years old, they can still cut these trees for timber and use them to make furniture. And they sell this wood all over the world for furniture. It's a highly desirable product, and so this is why we know so much about it too. And sometimes science takes advantage of the fact that because it's popular wood and there's an economic benefit to actually finding this stuff, scientists can piggyback on that other people's labor of digging this stuff up, and we can look at those trees and ask different questions that the person looking for an economic gain is not really necessarily going to ask. So first thing I want to point out is these trees, aside from, Taz Walker wants to say that, okay, so here's this tree there, but, I forgot to mention one thing. He does have a creative answer for why a tree that was before the flood now is living. Now there are living trees that are the same as the tree before the flood in the same place. And his response to that is, well, maybe these floating logs, right, ended up being placed on the surface of New Zealand, and then sprouts from those logs generated a new forest that would be of the same species. And that's why the same species of this particular type of tree lives in New Zealand, and you also find fossils of the same tree in New Zealand as well. Still don't know why some of these logs would have dispersed and been found in other places, but we'll give them credit for that. That is a plausible scenario. But I want to show you that there's been a continuous forest for a long time there. So people have looked at pollen profiles in lakes and sediments. These would definitely be all post-flood sediments on New Zealand. And when you dig down in those sediments and you do the carbon-14 dating, there are carbon-14 dates that are 26 to 30,000. I'm not showing you down here. They go down to 50,000 years old. So there are lakes and valleys that have been cored in which you look back at the past 50,000 years of carbon-14 dates, and all of that contains a lot of pollen from these particular types of trees, and also includes subfossil wood specimens, and leaves have been found in the same places where the forests are living today, showing a continuity of this forest for a long period of time. Now, so what does Taz Walker do with this? If you're looking at a column of sediment from a lake, and it goes all the way back to 50,000 years. Well, he's just said that tree dated to 42,000 years must have been pre-flood, because his model of carbon-14 dating is that is actually a date that's from 5,500 or 6,000 years ago, which would be close to creation, and so therefore before the flood. But here you have a lake that has a continuous sediment column that's sitting on top of a mountain, all right? And that mountain's created from sedimentary rock that is said to come from the flood. So the sedimentary rock had to have been formed first, and then there's a lake in it, and in the lake you have 50,000 years of carbon dated material. Taz Walker cannot try to place all of that, half of that column, the part that goes from 25,000 years to 50,000 years, which he thinks is carbon-14 dated to pre-flood. How would those sediments have come from the pre-flood time when they're sitting inside of a bowl of mountains that were created by the flood itself? You see how this gets all contorted very easily when you start to apply it to real situations. Remember, his article only just looks at that tree and says, oh, look at this tree found. I can explain that tree. Doesn't talk about the context. Doesn't talk about all the other trees that are found. Doesn't talk about articles like this that talk about the continuity of forest in the same location for 50,000 years. All right, so this is just showing some of the sizes of the trees that are actually pulled out of the soils and showing what a good condition they're in. I don't know how old this one is, but even if it's could be 10,000 years old and still be ready to be cut. Now, here's the other problem that Taz Walker has. He has not also acknowledged the fact that it's not just 50,000-year-old trees, but as you can see from this New Zealand Journal of Botany, there are late Oligocene and early Miocene, so million-year-old fossils that confirm a long history of Agathis in New Zealand, way more than 50,000 years. So if you go down here, there is a mine that was, there's a coal mine down here. And this is at the very bottom of New Zealand. Remember, today they only live here. And there's a 50,000-year record of forests living here, but there's no record in recent past of them living here. But down here we've got million-year-old fossils, specimens. And these are coal beds. And these coal beds are not that old. And even in most young Earth creationist chronologies, these are post-flood carbon remains, not pre-flood carbon remains. And so there's evidence all over the islands of fossilized versions, real fossils, not subfossils, which is what's found up here of this wood. All right, so back to our tree. So you take that tree, you wash it off, and then you slice it up. And this is what's been done in the last 2 years. Take a slice of it, count the rings, but more than count the rings, you're very carefully analyzing the rings for the ring width, which suggests something about the growing conditions during that particular year in which the ring was laid down. And from that, you can do something called dendrochronology. Dendrochronology allows you to put together, so if you have one log and it has a particular pattern of rings, and the pattern of rings represents decades-long shifts in climate. So you had a bunch of good years, a bunch of bad years. That could be cold versus warm, or wet versus dry years. And then you take another log that might have been from a tree that had lived earlier, hundreds of years earlier, but it overlapped in time. And if it overlaps in time, you can find the overlap in the similar ring profiles. And so then you're connecting those two, right? So you're saying, well, now I know the history from this time all the way up to this time. And then because there's an overlap here, I can go all the way up to here. And then there's an overlap with that tree, with a tree that started to grow in the last 100 years of the life of this tree, but it's the first 100 years of the life of this tree. And then I can look even out here into the more recent time of that. And so if you can find enough trees, and so you could find timber from older houses from the 1800s. You could find modern homes. You could find logs that are still just buried in the top soil layers. And then you could find trees that are buried way deep in swamps that are much, much older. You could possibly connect all of these different trees together by looking at the ring structures and form what's called a dendrochronology or a chronological map of time, spanning all these different trees. This has been done in northern New England because there is such a wealth of these particular trees that are preserved, and they preserve so well. And the general climate of the northern New Zealand is kind of uniform across that whole region. And so you can find trees from all over, and they have the same kind of ring patterns. So you can connect these trees up. This has been done for the recent past. So there's a 4,500 year dendrochronology that seems to be completely connected over 4,500 years. Then there are other chronologies from 5 to 8,000 years, and there's one from like around 11,000 years to 13,000 years, and they're just missing trees between those two, or at least they're not clear enough that they can connect them all together. But the point is that beyond the 4,500 years, there's older trees that they know are older because of carbon-14 dating and because their ring profiles don't match with anything in the last 4,500 years. And those chronologies are called floating chronologies because they're not directly tied to the modern chronology, but they're older. That in itself tells us that, strongly suggests to us that there is a history of the world being recorded in these swampy valleys in New Zealand that's 10 and 20 and 30,000 years old. And then, of course, we come to our tree of special interest, which is our 41 to 42,000 year old tree based on carbon-14 dating. And from that one, they've done a profile of 1,700 years. And then they've connected that tree to other trees that span on either side of that. So we actually have a dendrochronology of in the 41 to 43,000 year old time range, which doesn't overlap with the patterns from anything in the last 4,500 years. So maybe Taz Walker's right, that those trees, they certainly can't represent anything in the last 4,500 years because they don't fit inside of any of the patterns from the last 4,500 years. And the carbon-14 dates are older. So he has to push those trees to pre-flood times. Nonetheless, you're adding in more than 1,500 years into that previous chronology, which doesn't even fit into the creation to the flood time. He just can't find enough time to fit these trees. All right, that brings me to the. I was going to mention the 4,500 year chronology, which I already did. That brings us to today and the science paper that's being talked about quite a bit. This is making a lot of news because this group is taking this chronology from 42,000 years ago and saying that embedded in that tree is evidence of a polarity reversal, right? Polarity reversal is when the north and south pole magnetic poles swap, which has happened in the history of the Earth many times. But this is the most recent time that it's happened, right? In conventional geology and the timing chronology of the world, there's this event that occurred very quickly between 41,000 and 42,000 years ago. When the magnetic field collapsed, the poles are reversed, and eventually they're reversed again just 400 years later, and then have the magnetic field rebuilt itself a little bit since then. Well, what happens when the magnetic field collapses is that there's less protection to the Earth from cosmic rays. Cosmic rays are the things that bombard the atmosphere of the Earth and produce things like carbon-14. And so during that time period, there's an influx of greater amounts of carbon-14, which can be measured in things like trees, which are growing during that time. And so they could potentially capture the signal of a magnetic reversal. That's why this tree is so special and why so many people have worked on it, because once they identified it as being the same age or actually spanning the period of time that geologists have discovered from other places in the world is the time of the last reversal, they said, oh, look, we actually have a finely scaled map of tree rings, which if we went into each tree ring and analyzed some of the chemical nature of that and the various isotopes there, we might be able to see the reversal, the magnetic reversal happening inside of that tree, because that tree is recording it as it goes. And that's what they did. And one thing we see is, this is from that paper, from that science paper by Cooper et al. From this past week. As we see that right here in the 42,500 years ago to 42,000 years ago in this 500-year range, we see that the ring width is quite a bit larger, and then it comes down again. So they can see differences in growth rates of the tree at that particular time. But what's more important is that it's at that particular time frame when you have a spike in things like beryllium-10 production. That's also predicted from more cosmic rays reaching the Earth should increase the amount of beryllium influx into the atmosphere, and that should be captured in various places. So this is just one example showing that if you're looking at production of beryllium and how it's preserved in different places, there's a lot more of it being preserved at this particular time. So this is one of the evidences of a magnetic reversal. So where does the magnetic reversal come in? So I'm not interested in talking about the magnetic reversal so much as I am relating this back to Taz Walker. All right, Taz Walker is trying to say that this tree was a pre-flood tree. However, in all the young Earth creationist literature, which rarely talk about magnetic reversals, but when they do, this last reversal is always found in sediments and other places, in all of the places in the world, in what there's considered by virtually every single young Earth creationist as being a post-flood event. Now, this tree shows pretty clear evidence of having lived during that last magnetic reversal, or during a magnetic reversal that appears to be about the same length and time as the one predicted in other places in the world. So that is at least evidence that this tree was alive during that particular reversal. And since that reversal occurred in other young Earth creationist literature as being a post-flood event, this tree must have lived post-flood. When you start to connect the dots of all these different things, the young Earth creationist story, in which they try to provide simple explanations for seemingly difficult things to explain, like where's a 1,500-year-old tree come from? They want to try to find an explanation for it, but their explanation often contradicts their explanation for lots of other phenomena they've already explained in other ways. That's the sign of an inconsistent theory. And an inconsistent theory is a sign that you're probably wrong in your assumptions about the age of the Earth. All right, so we find that massive trees lived thousands of years ago, and this is just one of them. There are hundreds and hundreds of these trees that are absolutely enormous, that are preserved, some of which are thousands of years old, and they themselves have been buried for thousands of years. So this is really strong evidence that the world is more than 4,500 years old, at least going back to the last flood, to a global flood. The radiocarbon dates of these trees span thousands of years. In fact, the radiocarbon dates of these trees essentially span from 0 to 50,000 years old, which is the extent at which we can measure radiocarbon dates. Oh, those fossilized coal deposits, those are older than 50,000 years. They don't really have any much carbon-14 in them at all, and so they're considered to be much more ancient. So New Zealand appears to have been around a long time. It's had this particular type of species of tree living there for a long period of time and being preserved as fossils and then subfossils later on, and then modern trees today. So these do not appear to be trees that lived before Noah's flood, as Taz Walker is suggesting. However, if they're not, he has a whole other set of problems that he needs to explain. All right, small introduction to Dendrochronology and a look at an interesting tree from New Zealand. Thanks for listening.